Hello everybody and welcome back to Maths with Miss Buick. In these videos we're going to be looking at complex numbers. So let's focus first of all on what is a complex number. So z is equal to a plus or minus bi. Z is the letter we always use to denote complex numbers in senior cycle maths. So a is the real part and b is the imaginary part of our complex number. So we're going to start off by simply plotting some complex numbers of the form where there's the real part and where there is the imaginary part. Here we have an xy axis, as you'll know from coordinate geometry, but in complex numbers our x-axis is our real axis, so RE, and our y-axis is called our imaginary axis. So we can see here that I've plotted from -2 to 2 and -2 to 2 on my real and imaginary axis. So let's plot 2 plus 2i. Well, 2 is on the real and also 2 is on the imaginary. So 2 on the real and up to 2 on the imaginary. So you get 2 plus 2i. 1 on the real and -2 on the imaginary. So we've got 1 on the real, -2 is down here. So 1 minus 2i. And then we're going to do -2, -1. So here's -2 on the real, and then we're down to -1. So that there will be -2, -i. Okay, so that's how we plot complex numbers on our real and imaginary axis. Now let's look at adding or subtracting complex numbers. So the general rule here is we add the real with the real and the imaginary with the imaginary. So 4 plus 7 is 11. And then 3i minus I is plus 2i. So we add the real with the real and the imaginary with the imaginary. Multiplication of complex numbers, well, you can see it's very similar to multiplication in algebra. So we've got two brackets. We'll divide our bracket like we would do in algebra into two parts. So we start off by rewriting 3 bracket 5 minus 4i plus I bracket 5 minus 4i. Okay, so we have 3 by 5 is 15 and 3 by -4i is -12i. I by 5 is 5i and I by -4i is -4i squared. In your leaving cert, you're always going to be told what I squared is. So I squared equals -1 at the top of your exam paper. So we're going to take out the I squared and replace it with -1. But we might as well tidy up as we go. So we've got -12i plus 5i, so we get -7i. And then -4 by -1. And -4 by -1 is +4. And then we add the real with the real. So 15 and 4 is 19 and take away 7i. So there we go. So we have 19 minus 7i. Now let's move on to the next question. So we have z1 is 2 plus I and z2 is 5 minus 3i. And we have to find z1 bracket z2 minus z1. So let's begin by substituting in the complex numbers. So we'll take out the z's and put in the complex number instead. So here's our z1. So we're going to put in 2 plus I. And our z2 is 5 minus 3i. As follows, like this. Now it's important you put in your bracket here because we're putting in z1, which is 2 plus I, and it's been taken away. So we have to multiply in the minus in here and in here. So we have 2 plus I, and let's tidy up the bracket. There's my 5 minus 3i, and minus by 2 is -2, and minus by I is -I. So we'll continue cleaning up the bracket. We're going to add the real with the real and the imaginary with the imaginary. So 5 minus 2 is 3. And -3i minus I is -4i. So now you can see here that we're multiplying the 2 plus I by 3 minus 4i. So let's do that over here. We'll put a bracket around this just to make it look like the last question, where we take our first bracket and divide it in 2. So here we have our 2, and we're putting in 3 minus 4i plus I by another 3 minus 4i. Okay, so let's multiply. We have 2 by 3 is 6. 2 by negative 4i is negative 8i. I by 3 is 3i. And I by minus 4i is minus 4i squared. Let's tidy up. And don't forget that I squared is minus 1. So we're going to firstly add minus 8i plus 3i. And then replace the I squared with negative 1. Add the real with the real. So 6 and 4 is 10 minus 5i. So you can see there that there's quite a lot of work in these questions, but after a bit you can start to skip, I suppose, a few steps. But at the moment I'm trying to show you the full method so you can see exactly what I'm doing. So the answer there to question I is 10 minus 5i. Now on to our final question, where we have I multiplied by Z2. So we keep our I and we replace it with Z2, and Z2 is 5 minus 3i. Now we're going to multiply in the I. So we have I by 5 is 5i, and then I by negative 3i is negative 3i squared, and we know I squared is minus 1. So let's replace that with a minus 1. Minus or minus is a plus 3, but we know complex numbers are of the form the real first and then the imaginary, so let's put the 3 in the front. We're done. So our answer to this question is 3 plus 5i.